Today we will discuss general second degree curve. This type of the set of order pair x comma y where ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, which is called the general second degree curve equation. Sometime it may be represent a single line, a pair of lines, intersecting lines, or parallel lines, or sometime it may be parabola, ellipse, hyperbola, etc. For certain condition, the solution set of this equation is null set also. So there are possibility null set, line, pair of line, intersecting line, parallel lines, hyperbola, ellipse, parabola. Circle also is called a quadratic curve or a second degree curve where a square plus b square not equal to 0, because of we want quadratic general second degree curve. Let's take theta rotation of the axis, because we want to remove this term. So after theta rotation, new coordinate x dash y dash in terms of we want to represent this coordinate in old coordinate. The rotation metric is cos theta minus sin theta cos theta x dash y dash. So we have this one ax square, but x is what? X dash cos theta minus y dash sin theta, this one. So this x is replaced by x dash cos theta minus y dash sin theta. So a into this square plus 2hxy. X is this x dash cos theta minus y dash sin theta, and y is this x dash sin theta plus y dash cos theta plus by square. Y is what? X dash sin theta plus y dash cos theta whole square plus 2gx. X is replaced by x dash cos theta minus y dash sin theta plus 2fy, this one, but y is x dash sin theta plus y dash cos theta plus c equal to 0. So the equation transform into this. After expanding and adjusting the terms, we have this one a cos square theta plus 2h sin theta cos theta plus b sin square theta into x dash square plus minus 2h sin theta cos theta plus 2h cos 2 theta plus 2b sin theta cos theta into x dash y dash plus a sin square theta minus 2h sin theta cos theta plus b cos square theta into y dash square plus 2 into g cos theta plus f sin theta into x dash plus 2 into minus g sin theta plus f cos theta into y dash plus c equal to 0. Expanding all such terms and readjusting terms, we have this equation. But we want to eliminate this term x dash y dash. So we require this term is 0, this one, multiplier of x dash y dash, minus 2 sin theta cos theta plus 2s cos 2 theta plus 2b sin theta cos theta. This we want 0. So now we choose theta so that this one here a minus a sin 2 theta, trigonometry geometry identity, minus a sin 2 theta plus 2h cos 2 theta plus b sin 2 theta. So we want this 0. So we readjusting this, we have 2h cos 2 theta equal to a minus b into sin 2 theta, where 0 less than theta less than pi by 2, this one. So tan 2 theta is 2h upon a minus b for a not equal to b, and for a equal to b, theta equal to pi by 4, because a equal to b, this becomes infinite, so this becomes pi by 2, so 2 theta is pi by 2, that is theta is pi by 4. This selection of theta gives us an equation in x dash y dash with no term in x dash y dash, that is coefficient of x dash y dash is 0, and this is the intention behind the solution. And if h equal to 0, there is no need of rotation. So considering this value of theta, the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 transforms to this. See here, this term we have made 0. Suppose this one multiplier of x dash square, suppose capital A, this term becomes 0. Suppose multiplier of y dash square is this one b, and and suppose this x dash multiplier of this 2 into this, it is suppose G, capital G, and this suppose capital F, and as it is. So this equation transforms to ax dash square plus by dash square plus 2gx dash plus 2fy dash plus c equal to 0. Equation number 2. Okay. For this equation, ax dash square plus by dash square plus 2gx dash plus 2fy dash plus c equal to 0. Case 1, a not equal to 0, b not equal to 0. This is the equation. Ax dash square plus by dash square plus 2gx dash plus 2fy dash plus c equal to 0. Making perfect square for this x dash square x, and last time we will find out. So readjusting and perfecting, making perfect square, we get a into x dash plus g by a whole square plus b into y dash plus f by b whole square. So we have to add some certain term both the sides. So here g square by a plus f square by b minus c. Making perfect square, ax dash square, simply this term and this term, taking common a. So x dash square plus 2g by a x dash, but we are adding perfect square term. So g square by a square, this one. So this is extra term, a into g square by a, that is g square by a. So we have added both the sides. Now shift the origin to minus g by a minus f by b, this one. X dash, we can write x dash minus g by a, here y dash minus f by b. So shifting the origin to minus g by a minus f by b. So removing these terms, linear terms. Now without changing the direction of the axis, this equation reduces to this one, say epsilon square, a epsilon square plus b eta square equal to some constant k, where epsilon is x dash plus g by a and eta is y dash plus f by b. This is the standard form. Here, if k equal to 0, and AB are of opposite signs, then a epsilon square plus b eta square equal to 0 represents a pair of lines passing through minus g by a minus f by b. If k equal to 0 and a and b are opposite signs, this one. So this represents a pair of lines passing through origin, old coordinate. And second, if k not equal to 0, then we can write this equation in this form: epsilon square by k by a plus eta square by k by b equal to 1. Dividing both the sides, this equation, dividing both the sides by k and readjusting the terms, we have this. If k by a and k by b are of positive and unequal, this equation represents an ellipse. And if k by a and k by b are opposite signs, then it represents a hyperbola. And if k by a less than 0, k by b is less than 0, no point, because these two terms are negative. It is not satisfy, it does not satisfy any point. Then no point satisfies the equation. And third, if k not equal to 0, this one, and a and b are equal, and they are positive, then equation represents a circle. Now we will discuss case 2. Okay. Now case 2, a equal to 0, b not equal to 0. So from equation 2, ax dash square plus by dash square plus 2gx dash plus 2fy dash plus c equal to 0. We have taken a 0, so this term cut out, and making perfect square and taking common b into y dash plus f by b whole square plus 2g into x dash plus c by 2g minus f square by 2bc equal to 0. Then shifting the origin to this one, x coordinate is this, opposite of this, minus c by 2g plus f square by 2bc minus f by b. This is x coordinate. Origin, shifting the origin to this x coordinate and this y coordinate. It reduces to this one, eta square equal to minus 2g by b into epsilon. Because of this one becomes new y, say y double dash, and this one becomes new x, say x double dash. Here this one is represented as epsilon and this one is represented as x epsilon and this one y eta. So where epsilon is x dash plus c by 2g minus f square by 2bc and eta is y dash plus f by b. This equation represents a parabola. If g equal to 0, by dash square, if g equal to 0, by dash square plus 2fy dash plus c equal to 0. Also b not equal to 0. If f square is greater than bc, these represent two horizontal lines, and if f square is equal to bc, it will represent one line parallel to x axis. If f square is less than bc, no point will satisfy the two equations. And case 3, same case, vice versa. A equal to 0, b not equal to 0. Now we have taken a not equal to 0, b equal to 0, same method. So as in case 2, it can be shown that the equation represent a parabola or lines. And case 4, a equal to 0, b equal to 0. We have initial taken condition a square plus b square not equal to 0, so this is not possible. Still, if we take a and b both are 0, this rest equation represent a line. Okay. Now another method, general second degree curve, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. What it does which figure it represent? It depends on a, h, b, g, f, c, etc. Sometimes the solution set is null set, sometimes a single line, sometimes a pair of lines, either parallel or intersecting. Sometimes it represents circle, sometimes it represents ellipse, sometimes it represents parabola, sometimes it represents hyperbola. So there are these type of possibility. Sometimes it represents just a single point. So null set, point, line, pair of line, intersecting lines, circle, parabola, ellipse, hyperbola. All are in this equation. After theta rotation of the axis, we want to eliminate this term. So x, y is cos theta minus theta sin theta cos theta into x dash y dash. So x is x dash cos theta minus y dash sin theta, this one, plus 2h into x y, so x dash cos theta minus y dash sin theta. Y is x dash sin theta plus y dash cos theta. Plus by square, y is x dash sin theta plus y dash cos theta whole square plus 2gx, x is x dash cos theta minus y dash sin theta plus 2fy, y is x dash sin theta plus y dash cos theta plus c equal to 0. Expanding and readjusting the terms, we get this: a cos square theta plus 2s sin theta cos theta plus b sin square theta into x dash square plus minus 2a sin theta cos theta plus 2h cos 2 theta plus 2b sin theta cos theta into x dash y dash plus a sin square theta minus 2h sin theta cos theta plus b cos theta into y dash square plus 2 into g cos theta plus f sin theta into x dash plus 2 into minus g sin theta plus f cos theta into y dash plus c equal to 0. If we choose theta such that the coefficient of x dash y dash becomes 0, that is 2h cos 2 theta is b sin 2 theta, this one, a sin 2 theta, this side. So 2h cos 2 theta is a minus b sin 2 theta, that is tan 2 theta is 2h by a minus b. So if we select, because we have equations, so we have h, a, b, etc. So tan theta is known value, so 2 theta is known, and so theta is also known. So if we rotate this by axis by theta rotation, we can eliminate this term xy. Now the equation 1 transforms to ax dash square plus by dash square plus 2gx dash to plus 2fy dash plus c equal to 0, where a square plus b square not equal to 0. The equation number 2. This and this, taking common a, x dash square plus 2g by a into x dash plus last term perfect square g square by a square we have added. So ultimately we have added a into this, that is g square by a. So we will add this side also, and from this term b y dash square plus 2f y dash, taking on b, y dash square plus 2f by b into y dash plus f square by b square, we have added this term to make the perfect square. So b into this term, extra term, that is f square by b, so we have added this side also f square by b, and c is this side, so minus c. Now this term a into x dash plus g by a whole square plus b into y dash plus f by b whole square equal to g square by a plus f square by b minus c. Now shifting the origin to this minus g by a minus f by b. The new coordinates epsilon equal to x dash minus g by a and eta equal to y dash minus f by b. So this equation reduces to a epsilon square plus b eta square equal to, suppose this one is k, capital K. Now product of these two terms a into b. What is a? A is multiplier of x dash square, this one, a cos square theta plus 2 sin theta cos theta plus b sin square theta. This is a. And what is b? The multiplier of y dash square, a sin square theta minus 2 sin theta cos theta plus b cos square theta. So if we multiply these two terms, we have a cos square theta into whole bracket plus this into whole bracket, this into whole bracket. We get this a square cos square theta sin square theta minus 2a sin theta cos cube theta plus ab cos theta raised to 4 plus 2a sin cube theta cos theta minus 4a square sin square theta cos square theta plus 2b sin theta cos cube theta plus ab sin theta raised to 4 minus 2b sin cube theta cos theta plus b square sin square theta cos square theta. There are 3 term here, 3 term here. So there are 9 term, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now readjusting terms, this term and this term, simultaneously ab into sin theta raised to 4 plus cos theta raised to 4. Simply observe these terms, a square plus b square minus 4a square into sin square theta cos square theta. And this one 2a sin theta cos theta into bracket minus a cos square theta plus a sin square theta plus b cos square theta minus b sin square theta. We have adjusted these terms this like this. Observe this. You can check your self calculation. Okay. Now readjusting the terms ab into sin theta raised to 4 plus cos theta raised to 4 plus a square plus b square minus 4a square sin square theta cos square theta plus 2s sin theta cos theta minus a into cos square theta minus sin square theta plus b into cos square theta minus sin square theta. So ab into this one, this expression we can write this way, sin square theta plus cos square theta whole square minus 2 sin square theta cos square theta. This one as it is, and this one we can 1 by 4 into 4 sin square theta cos theta, because of this term is sin 2 theta whole square. This one minus, taking common cos square theta minus sin square theta, and it is cos 2 theta. Taking common cos square theta minus sin square theta, and it is cos 2 theta, and minus also we have minus h sin 2 theta cos 2 theta into a minus b. So we have taken minus into bracket cos square theta minus sin square theta common and applying trigonometry rules, because of cos 2 theta is cos square theta minus sin square theta. So AB is 1 minus half into sin square 2 theta because of 2, but we want 4 here. So half into 4 sin square theta cos square theta, that is half into sin square 2 theta plus plus bracket a square plus b square minus 4a square 1 by 4, it's sin square 2 theta minus h into a minus b into sin 2 theta cos 2 theta. But tan 2 theta is 2h by a minus b. So trigonometry geometry, this is suppose 2 theta, this is opposite side, this is a minus b. So hypotenuse is of root of 4h square plus a minus b whole square. So if we put all such values from this trigonometry, sin 2 theta, sin 2 theta, sin 2 cos 2 theta, we have AB into 1 minus half into sin 2 theta, that is 2h by hypotenuse. Hypotenuse is a minus b whole square plus 4h whole square root. But here square is there. So 1 minus half into 4h square upon a minus b whole square plus 4h square plus a square plus b square minus 4h square as it is 1 by 4 sin square 2 theta, same term here, 4h square upon a minus b whole square plus 4h square minus h into a minus b sin 2 theta is 2h upon hypotenuse, which is root of a minus b whole square plus 4h square into cos 2 theta is L side upon hypotenuse, so a minus b upon root of a minus b whole square plus 4h square. Now this term, they all come having this a minus b whole square plus 4h square. So here taking LCM, AB, a minus b whole square plus 4h square. So here a minus b whole square plus 4h square minus 2h square. Here they are in multiplying form, so as it is s square into a square plus b square minus 4h square upon a minus b whole square plus 4h square. And this term, for this term, minus 2h square into a minus b whole square. See here, minus 2h square into a minus b whole square upon square root. So square is there, a minus b whole square plus 4h square. Okay. Now simplifying the terms, taking LCM a minus b whole square plus 4h square, this is in division. In numerator, AB into bracket a minus b whole square plus 2h square plus s square into a square plus b square minus 4h square minus 2h square into a minus b whole square. See, the denominator is always positive. Always positive. So sin of a into b, this is the product of a and b, which are the coefficient of x dash square and y dash square. So sin of a into b depends on the sign of numerator of this, because of the denominator is positive. Sign of numerator, which is ab into a minus b whole square plus 2abh square plus a square h square plus b square h square minus 4h raised to 4 minus 2h square into a minus b whole square. So this is equal to ab into a minus b whole square plus h square into a plus b whole square. These three terms we can take common h square. So a square plus 2ab plus b square, so a plus b whole square minus 4h raised to 4 minus 2h square into a minus b whole square. Let d equal to ab minus h square. If we suppose d equal to ab minus h square, that is ab equal to d plus h square. So substituting ab equal to d plus h square in above expression, we have d plus h square into a minus b whole square plus h square into a plus b whole square minus these two terms, taking common h square, a plus b whole square minus 2 into a minus b whole square minus 4h raised to 4. So d plus h square into a minus b square plus h square, expanding this, we have 6ab minus h square minus b square minus 4h raised to 4 as it is. So d plus h square into a minus b square plus h square into 6, ab is again d plus h square minus h square minus b square minus 4h raised to 4. So d into a minus b whole square, separating this, h square into a minus b whole square, 6dh square, 6 h raised to 4 minus h square a square minus h square b square minus 4h raised to 4. So this term, expanding this, d into a minus b whole square, 6dh square, this one h square a square minus 2abh square plus h square b square, and this one minus h square a square minus h square b square plus 2h raised to 4, because of these two terms is 2h raised to 4. This cut out, this cut out. We have d into a minus b whole square plus 6dh square minus 2h square into ab minus h square. But this one is again d. So d into a minus b whole square plus 6d square minus 2s square into d. Taking common d in all the three terms, d we have into a minus b whole square plus 6s square minus 2s square. So equal to d into a minus b whole square plus 4s square. But this one is always positive. So this one, product of AB, the sign of product of AB, that is whether it is positive, negative or 0, it depends on d only. And what is d? AB minus s square. And delta is class 12 maths AFG, HBF, GFC determinant. And we have selected d is AB minus s square. Now the cases are there. If d equal to AB minus s square positive and a not equal to b, delta not equal to 0, then it is ellipse. And if d is greater than 0 and a equal to b, delta not equal to 0, then it represents a circle. And if d equal to ab minus s square negative, delta not equal to 0, then it is hyperbola. And if d equal to ab minus s square is equal to 0 and delta not equal to 0, then it represents parabola. And if d is positive, delta 0, then point or empty side. If d negative and delta 0, pair of intersecting lines. And if d 0, delta 0, pair of parallel lines or coincident line or null side. That's long theory completed.